Welcome back, everybody, and let's look at the bearings and slope and the grade for this chapter. And the bearing is the direction of a line as is drawn in the top view of a drawing on the map. So your bearings, if you haven't uh, taken my class, you probably won't know what the bearing is. And for those who already took surveying 1A and 1B, and they are very well versed in this bearings. So to read the bearings, for example, for this case, you will read them as north 45 degree west, and for this case, you would read that as south 30 degrees east. For this case, you would read it as north 45 degree west. And for azimuth, so azimuth is a little different. Azimuth is going to read starting from north to whatever the angle you want to be read. So for this case, you have 90, 90, 90 plus 45, total 35, 315 degrees. So the azimuth bearings is 315 degrees. And the slope angles of the line 1 to 2 and the horizontal line give you, whenever they give you the horizontal line, that's give you the slope angles. If you don't get the horizontal line, it's not level, you don't get the slope angles. So for this case, you're given the top view and the front view. And one thing I want to tell you is that the horizontal line can only be found by projecting from the top view, not from the front view. The front view is not a horizontal line. If it's not a horizontal line, that means it's not the true angles. And whereas this one here, the top view, this is your true horizontal line, and this is your true slope angles. So this is to determine the percent of grades, and the formula for determining the percent of grade is unit of vertical rise over run. The rise over horizontal time 100 will give you the slope. For this case, you have 85 excuse me, 85 run over horizontal 148 times 100 is going to give you 57 degrees slope. So for this case, 100 divided by 100 will give you 45 degrees, and it's 100% grade. And slope of the roof, and this is the slope of the roof, and it's a ratio of vertical rise for every 12 inches or 12 feet of the horizontal span. So 12, so every 12 feet or 12 inches give you the slope either down or up to whatever that number is, 6 for this case. So for the bevel is used in structural engineering to indicate the slope of the structural member. And for better identify the grade of the earth. So better is used in civil engineering field to indicate the slope of a grade. Angles between the bearings or heading. So given this, and from here you can determine what the angles is. Given the north is here, north 15 degrees east, north 80 degrees east, you can determine what the angle is by subtracting here. So you have 15, you have 80. So if this is your 80, so 80 minus 15 will give you the angles. And how to calculate the angle between the heading in one quadrant. So you have 80 minus 16 is going to give you 80 minus 16 65. So same thing, angle between two heading in 3 quadrants. If it's 3 quadrant, same thing, you would draw angles here, draw here. So we have 90 degrees. And then south, here, south is 60 degrees. And then you have northwest 15. So 15, 90 plus 90 minus 60, you got 30 here. So add them up will give you a total of 135. So the line bearing north 60 degree is 15 degree plus the slope 232 length. So here, given the angles here, given the bearings, north 60 degrees is, you get 60 degrees, is 15 degree plus the slope. So you have a slope of 250. So you have 15 degree. This example here is to show you constructing a line with a specified bearing, slope, angles, and length. So if they give you, given this line bearing, and then give you the slope angles, give you the true length, and now you can find out you can construct a line with this given information. So A, given this point A at the top view, point A at the front view, project north 60 degree east for 250 feet, and then you're gonna get, once you have AT to BT, now you're gonna determine the 250 with, this is your horizontal line, and 15 degrees going down, this is your slope, your true angles, and that's how you determine your this line here and this line here, true bearings. The true bearings can be found from the top view, and then this is your auxiliary view to get the true length. And if you project them, you can connect them and get the front view. So same thing, line bearings given north 45 degrees west, 40% grade, and 190 true length. So given point A at the top view, so you're gonna first draw the 45 degrees west, going 45 degree west, and then you have this bearings here, and once you get your AT here, now you're going to draw the auxiliary view. From this auxiliary view, you're going to get 40% grade. So 40% grade at 192 length. 192 length. So this is 192 length. At 40%, 40% means 40 rise over 100 will give you 40%. So once you determine this true length, and you can come back and project this the front view, and the front view is the same distance here. So you have the front view here. This distance is equal to this distance. Okay, so how to plot the boundary of real estate? So given this bearings, and now you're gonna start with, to draw this bearings, this is your starting point. You're gonna start here, and then you're gonna draw north 58 degree 30 minute west from here. So you're gonna go north 54 degrees north 54 degrees, 30 minutes. So northwest. Okay, northwest. So from here, if this is your north, depend where the north is. So your north, this is your north. And if you want to go from this north, so your southwest, so this is your north. If this is your north, then you're going to have to draw this way. So your north, this is your south 17 degree west. You can draw that to 59 feet. Same thing, this is your north. And then you're going to draw south 41 degree west. So you're going to continue on with the same fashion and then to complete your traverse. Okay, I'm going to keep going to finish this chapter here. And to apply descriptive geometry and survey indicates compass direction with distances of the property boundary. Contour, this is a contour indicate the elevation of the earth compared to the sea level. As you can see given this contour map, and from the contour map, if you draw a line there, and you're gonna see this line here, given this elevation, 1000 at this point. So your elevation here is 1000. If you project all this line there, this is whatever the elevation of that contour will give you this point, and that's how you determine your profile, your elevation view. And then you can show the cut and fill based on what the existing versus the proposed. Whatever the existing, if this is your new row and this is your, in order to complete this new row, and you want to show this is your existing profile, existing line, and if you propose to cut it, this is how much you need to cut. And the example of proposed row, and if this is the proposed row at this elevation 500, so you're gonna draw all this line down here from each contour to find out what is your slope gonna be, and from here, if you draw this line, you can plot all this point. This is gonna be your street slope. So your street can be depend at what location, and your street can have a slope of this slope or the slope going down, depend which station you're looking at. So okay, we're gonna continue on to look at some of this cut fill boundary. To calculate the cut fill, you will draw the cross section of the street, and you're going to determine the area of this section. Find out what the area of this section, time the next intersection, the next cross section, and then multiply by the length of the intersection. It's going to give you the cubic feet, and then you would convert that cubic feet into either cubic yard if it's big quantity, or you can keep them as a cubic feet. And then of course now that we have AutoCAD, we can either digitize all this contour into AutoCAD, where you can create your DTM for the proposed, and then you can create your existing contour, and then run that quantity, and AutoCAD will automatically generate a cut fill report. And AutoCAD may not be able to do it. You need the third-party software, things like DTM and surveying package, or any third party may be able to calculate that cut fill quantity for you. But the old way, we would just use a digitizer, or we would just cut a section station by station, and then you calculate the area of each section, and then multiply by the length of the next section will give you the cut fill earthwork quantity. And vectors have both magnitude and direction, and are used in engineering. So you have both magnitude and direction. What is the weight and what is the distance is your vector. And things like it's not vector, this is not vector because they only tell you this is the 2 times this diameter of the hole. They don't give you the weight, they don't give you force, or they don't give you the direction. This is called non-vector. Whereas this is the vector, they give you force and the direction. Some of the like vector used in engineering simplification. So they tell you how much force is here equivalent with internal load. What is the load here? What's the load there? This is all vector. The load here is, and you call it a vector. And then a coplanar concurrent vector, adding vector parallelogram law, and then subtracting vector parallelogram law. So this vector here, to add this vector A and B, given positive here, your resultant is equal to A plus B. Whereas if the vector is reversed, negative here, positive going this way, and you're always positive here, positive there, negative here, negative there. So here, this is your negative, positive, positive. So for this case, your resultant is equal to A minus B. Okay, so we're going to talk about trusses and three-dimensional frame made of the structural shape and so on and so forth next online class, and we may just go over that in the class. For now, and this is your homework, problem 9-1, problem 9-2, and problem 9-3. When you finish all the homework, submit them online to get the full credit. But the rest of the lecture, we're going to finish it after Thanksgiving on Tuesday, and we should be done with this chapter next Tuesday. And again, we got Thanksgiving week, Thursday we don't have class, one more week next week of the month, and then your exam number 3, and then your final. And with that, we'll see you this coming Tuesday in Canvas.